Assalamu alaikum. In the previous video, we have completed the basics of Laplace transform, the formula and the existing conditions of our Laplace transform. Now in this video, we will complete a topic which is Laplace transform of some basic formula, which will be needed as a formula in our more complex math. So we will at first we learn this basic functions formula. We have said that the formula of our Laplace transform of any functions is, suppose f of t is a function, then the Laplace transform of this f of t function will be integration of 0 to infinity f of t e to the power minus st dt. Using this basic formula, now we will find some basic functions Laplace transform. Suppose f of t is a basic function. Now we will find a Laplace transform of this function 1. So we can write Laplace transform of this f of t function equals to Laplace transform. We'll write this according to our this formula. So integration of 0 to infinity f of t means our required function e to the power minus st and dt. So as our f of t equals to 1, so we can write Laplace transform of 1 equals to integration of 0 to infinity, and instead of this we'll write here 1 into e to the power minus st dt, which is meaning of this. Now from the integration we can write from this function as e to the power minus st divided by minus s, and as it is from 0 to infinity, now we'll get the limit is 0 to infinity. This is from our basic integration formula, we can write this. So from here we'll write, now we will put these two limiting value in our formula. If we separate this constant, then there will be remained just e to the power minus st, which is in the limit of 0 to infinity. So from here we can write that minus 1 divided by minus s, and we will put here at first the upper limit at the variable of this t, as it is a function of t, f of t, it is a function of t, and we integrate this in the term of dt. So instead of this t we will put here as infinity, so e to the power minus, if we multiply s into infinity, then it will be infinity minus this last limiting low limiting value, so e to the power minus 0. So this e to the power minus infinity means 1 divided by e to the power infinity, which means we know that 1 divided by infinity equals to 0. So the value of this term will be 0. Then the remaining part is 1 divided by minus s bracket 0 minus, we know that something to the power 0 equals to 1. So if we remove this bracket, then we'll get 1 divided by plus s. This is the Laplace transform of function 1. It is a basic functions Laplace transform. Now see another basic function. Now our second question is f of t equals to t, means this is a function of t and here our functions is also t. Now let's find the Laplace transform of this f of t function. So at first we will write down the basic formula of Laplace transform, which is integrate 0 from 0 to infinity f of t e to the power minus st dt. Now we will write the function as t. This is 0 to infinity t into e to the power minus st dt. Here we got two terms at the variable of t. So here we have two ways. One is we will use the uv formula, integration of uv formula, or otherwise we will apply the di formula. I think this formula is much easier for us from this formula, so we will use here di formula. Di formula is we will differentiate the one u term and integrate the another v term. Suppose this is u and this is v, then we will differentiate this u and will integrate this v. So if we differentiate, at first we will write down the functions t, and here will be e to the power minus st. So now if we integrate this t, then we will get, we will differentiate this t function, we will get 1, and if we integrate this we will get e to the power minus st divided by minus s. Then again if we integrate this, then we will get 0, or here e to the power minus s divided by minus s into minus s. But here is a formula that this first term will be plus, then second term minus, then plus, something like this will be continued, and we will stop if we get here 0, then we will stop our differentiation and integration. Now we will cross multiply as like this, and after multiplying this we will put here. So our first term will be t into this term, so we'll write down this t into e to the power minus st divided by minus s, and our second here we have to use this minus, and we will multiply this one with this term, then we will get e to the power minus st divided by s square. And now we'll write down the limit, which is 0 to infinity. If we separate the limit with these both terms, then it will be more easier to calculate. So we'll write as, by separately we can write this as like this. We just separate the limiting value for these both terms. Now if we put this limiting value, then we will get, at first we will put down this infinity, means higher limiting value. Then if we put this higher limiting value, we will get t as infinity into e to the power minus infinity. From here we see that e to the power minus infinity is tends to 0. So if we put this infinity term, then we will get as 0. And now if we put this lower limiting value, then we will get, we have minus for our integration formula, and then we will get another minus formula. Let's take a bracket, then t equals to 0 into e to the power 0 divided by s, means our this both term will be 0. And our, let's find out our second term. If this is the same case, e to the power minus infinity, so our first term will be 0, and if we put here as 0, then we will get e to the power 0 divided by s square. So from here we will find 0 minus e to the power 0 means 1, so 1 divided by s square. So if we remove this first bracket, then we will get 1 divided minus minus plus 1 divided by s square, where s is greater than 0. Because if s is less than, s must be greater than 0, because s square will be a positive sign for all the time. So the formula of f of t function, we will get the Laplace transform formula as 1 divided by s square. We will use this as a formula in our complex functions math. Now let's see another example, which is f of t equals to t square. This is also a function of t. Now let's do the Laplace transform of this function, which is Laplace transform of f of t. Now we'll write down the formula with this function directly. So we'll write 0 to integration from 0 to infinity f of t, means t square into e to the power minus st dt. So here we also see the uv term, and we will do the same thing, our di method. So here we will differentiate the t square, integrate e to the power minus st. We will differentiate this and integrate these terms until we get 0. So this will be plus, second term will be minus. If we differentiate this, then we will get 2t, and if we integrate this, then we will get e to the power minus st divided by minus s. Then thirdly, if we integrate differentiate this, we will get 2, and here we will get e to the power minus st divided by minus s into minus s, which is plus s square. And fourthly, we will differentiate this 2, we will get 0 as it is constant, and if we integrate this, we will get e to the power minus st divided by minus s minus s minus s, which is minus s cube. So now we will cross multiply these terms, and if we multiply 0 with something, then that will be 0. So we will multiply until this. Now we will write down these 3 terms, which is t square into this term, t square into e to the power minus st divided by minus s, then minus 2t into this term, 2t into e to the power minus st divided by s square, and our third term will be plus 2 into e to the power minus st divided by minus s cube, and we'll give the whole limit as 0 to infinity. Now we'll separate this limit for these 3 terms for our better easily understanding. So let's write down this. After separating the limit for these 3 terms, we get this. We also separate the constant term, as this is not included for our limit. So now we will put this limit for the variable t function, 1 divided by minus s. here if we put the higher limit, we will get infinity square into e to the power minus infinity, means here we will also get the e to the power minus infinity, which is equals to 0. So we will get here higher limit as 0, and if we put here 0, then minus 0 square e to the power minus 0. If we multiply something with 0, then we will get 0. So the whole term will be 0. Now let's see the second term, 2 divided by s square into, here we'll also find the same things, which is e to the power minus infinity. So our higher limiting value will be 0, and our lower limiting value will be 0 into e to the power 0, which is similar to this, means our whole term will be 0. And our third term will be e to the power minus s cube. Sorry, here will be plus. Then we will put here limiting value, e to the power minus infinity means 0, minus e to the power minus 0 into s means e to the power 0. So here our whole limiting value will be turns to 0, and if we multiply this 0 with 1 by minus s, then our whole term will be 0. Then if we will find that this term, we will also get 0, and if we multiply this with 2 divided by s square, then this will be also 0, and they are only lasting our last value, which is, if we this minus value, then will be this will be plus minus minus 2 divided by s cube, and here we get e to the power 0 means minus 1. So ultimately the answer will be minus minus plus 2 divided by s cube. So the answer of Laplace transform of t square will be 2 divided by s cube. Now if we find this as t cube t4 dot dot dot, then we will get a ultimate value for t to the power n. This is n factorial divided by s to the power n plus 1. So if we check this, then we'll check for t square, then it will be 2 factorial divided by s to the power 2 plus 1. 2 factorials means 2 into 1 divided by s cube, which is 2 to the power s cube, which satisfied our this formula. So this formula is true for all t to the power n functions.